Hello guys and welcome back to Caravan Academy. If you remember this face, you won't remember this face because it's my first time showing my face, but this is me who did up to question 6 on the 2018 paper. So we're going to be on question 7. If you haven't watched up to question 6, I recommend you to do that first and then come back. Or if you want question 7, just continue on. Stop with all the talking. Let's get on to the question. So, Table 8 shows information about some food components in cow's milk. How much more milk would a typical adult have to drink to get the RDA? RDA means a daily requirement. RDA for calcium, the recommended daily allowance, for calcium compared with the amount of milk needed to get the RDA for vitamin B12. So, for calcium, ooh, nice. For calcium, we can see that the RDA will be the 500 over the total amount of calcium, which is 605. Because we've got 500 centimeters cubed, we have 500 divided by 605. And then we multiply that by 1000. Because the 1000 here is the total amount of RDA for a typical adult. And this equates to 826.446281. And then for vitamin B12, we've got 500 of vitamin B12 again. Divide that by the 4.5 and then multiply this by 2.4. This is literally like proportion that you learn in GCSE maths. This equals 266.67. Therefore, the volume of the milk would be the difference between this and this. So if we do that, 826.4 for blah 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 minus 266.67, we should get an answer about 560 centimeter cubed, which is our final answer. This will give you the 3 marks. The next question. Describe how a student could test cow's milk to show whether it contains protein and different types of carbohydrates. I'm sure you loved your cow's milk when they came in cartons in primary school. And now we're going to be checking whether it contains proteins and different types of carbohydrates. Fun, ain't it? Okay, so for cow's milk to contain protein, the test for protein, what's that for? Mistake. Test for protein is that you add Biuret reagent. By the way, you have to learn this for A level as well, so don't forget it after you've done your GCSEs. You add Biuret reagent to milk. And then the solution will turn blue to purple, or you can call it lilac. Mark schemes would allow both lilac or purple. It's perfectly fine if positive. And then for starch, test for starch. Test for starch is pretty simple. It's your basic iodine test. So you would add iodine solution to sample. Remember, starch is also a carbohydrate. That's why we're testing for starch, because it's a carbohydrate. Add iodine solution, and the iodine solution would go blue, black. To be more specific, the color change would be actually from brown to blue-black. Goes brown to blue-black. Remember that, blue-black. Double B's, blue-black, blue-black, blue-black. And then for carbohydrate, so example for sugars, if you're doing A level, this will be called reducing sugar. You'll add Benedict's reagent, and then you would boil or heat at higher temperatures. And this would go to a brick red precipitate. B-R-I-C-K. Brick red precipitate. This is precipitate in short form, but please use the long form when you're answering exam questions. Next question. A scientist investigated the effect of bile. So bile is something that's stored in your liver, and it is to help emulsify fat, also known as breakdown fat. Like it says in the question helps. On the breakdown of fat in a sample of milk, the scientists used an indicator that is colorless in solutions with a pH lower than 10, and pink in solutions with a pH above 10. So colorless, there's a key words, colorless, pH lower than 10, and pink in solutions with a pH above 10. This is the method used. Add 1 drop of bile to a test tube. So always draw a diagram if it helps. So they're adding 1 drop of bile to a test tube, and then they're taking another test tube and then adding water, 1 drop of water. Add the following to each test tube. So each test tube has milk. To my chemistry friends, you can also have Na2CO3 or sodium carbonate. 5 drops of indicator. And then 1 centimeter cubed of lipase. So this is repeat for each of this as well. And then they say that time how long it takes for the indicator in the solution to become colorless. So we're going to time how long it takes to become colorless. Stopwatch. Colorless. So make quick hints when you're answering questions so that you understand what's happening. So they've shown that the solution without bile takes longer to become colorless than the solution with bile. So that is the gist of the answer to the question. Even without reading the question, they can just make a conclusion like that. Let's see what the question actually entails. Explain why the indicator in both solutions became colorless. So we're asking why it actually became colorless. So this is quite an interesting question, because it's actually not asking to compare the indicators like they usually do, but they're now asking why it actually becomes colorless. So the first thing is, because we have 1 centimeter cubed of lipase, and this question is mainly about enzymes, we can start by saying that lipase breaks down, or if you want to be posh and fancy, we can have hydrolyzers. Good term to use, hydrolyzers. The fat down to fatty acids. And then the fatty acids lowers the pH. If you don't know, the lower the pH, the acidic the solution. That is GCSE chemistry that they cover in year 7 or year 8 of the syllabus. And when fatty acids fatty acids cause the pH to be below 10. The indicator becomes colorless. So look at how I've structured my answer. They firstly start with the question is why the indicator, and those are very key words to include in the question. So indicator becomes colorless. So this means the end answer must lastly be with the word of colorless or color change. So in this one, we can see that lipase is an enzyme that breaks down the fat into fatty acids. And because the acids lower the pH, the fatty acids causes the pH to be below 10. Therefore, the indicator becomes colorless. Next question. Give the reason why the measurement of the time taken for the indicator to become colorless might be inaccurate. So this is because the observation of color change is subjective. For example, people may think this bottle of deodorant is grey-green, but I might think that it's got a bit of white in it. So it's a bit subjective. Explain the difference in the result for the two test tubes in Table 9. So in Table 9, one of the solution has bile and the other doesn't. So the main answer is going to be with bile or without bile. So we're going to firstly say that with bile, the bile emulsifies the fats. Always keywords is a key. Keywords is key. Bile emulsifies fats. And the emulsification creates a large surface area when you're talking about emulsifying, you have to be talking about larger surface area. Creates a large surface area. So lipase, don't say breakdown because breakdown is not very biologically correct. So lipase hydrolyzes. Even though the mark scheme may say breakdown, I would suggest using hydrolyzes because for those who are taking on biology for A level, they will be disregarded of marks when they say breaks down. So lipase hydrolyzes the fats into fatty acids more quickly. So that's the end of the paper. In my opinion, it's quite a good paper, this one, because it's got a lot of range of topics. It's got things like biological molecules. It's got some lung transplant questions. It's got a variety of questions we can do. Oh, sorry, we even forgot question 6. Oh no, question 6 wasn't in the marks. It was not relevant actually because they removed question 6. Okay, so that brings the end of the paper. I hope you enjoyed watching part 1 and part 2 of the paper, and I will see you on the next one. Thank you for watching Carbon Academy.